Lesson 7.4, adding and subtracting radical expressions. I'm going to start out in this lesson with dealing with addition, subtraction, and with numbers where you will use the product rule. That would be our first thing that we're going to work with in this lesson. And that's all you'll work with to start with. The second lesson will be working and using the quotient rule to help us with adding and subtracting them. So here we go. The first lesson though today is just using the product rule. But the basic idea is follows when we combine like terms with our equations. For example, 3x plus 5x, that together I can add my 3 plus my 5. It gives me 8 because I have a common factor of x, so I write 8x. When I subtract, it's 9y minus 2y, so then it's 7y. 9 minus 2 is 7, keep the common factor y. With radicals, it's the same idea. So if I have 3 times the square root of 5 plus 5 times the square root of 5, 3 plus 5 is 8. And since the radical the square root of 5 is the same in both, I'm going to write times the square root of 5. Same thing with subtraction. 9 times the square root of 10 minus 2 times the square root of 10. 9 minus 2, 7 times the square root of 10. And I'll keep that common factor that way. So what I'm trying to create is something where I have common factors that I can add the numbers in front or I can subtract the numbers in front. The problems aren't always going to be set up like this. They actually ask you to do extra steps. They're going to ask you to use the product rule to start with, and then we'll ask you to do some with the quotient rule. So I'm going to do about 3 or 4 examples here with you. I'm going to give you problems like this one. The square root of 50 plus 5 times the square root of 18. All right, in these problems, the square root of 50 can't be combined with the square root of 18. These radicals are not the same. So I look for perfect square factors. Are there perfect square factors that I can find in each of these and take those out and then check to see, hey, maybe I do have a situation like this. So we simplify first. The square root of 50 can be rewritten as the square root of 25 times the square root of 2. And note I wrote the perfect square factor first because when we write and simplify it, it'll give me a rational number. So that's always written first. The irrational was always written second. Plus 5, and 18 has a perfect square factor of the square root of 9 times the square root of 2. So now 20 square root of 25 times the square root of 2. 5 times the square root of 2. Plus 5, and the square root of 9 is 3. So 5 times 3 is, because this is 3, so 5 times 3, 15, times the square root of 2. Now I have in my situation here, I have a square root of 2 common factor, so I can add 15 and 5 together. So I get 20 times the square root of 2. And now I'm done at this point because there's no more perfect square factors in here. This would be an irrational number. It goes on forever. So I'll just stop and say this is 20 times the square root of 2. That's that simplified. Perfect cubes. Now instead of looking for perfect squares, I'm looking for perfect cubes. So if I kind of make a brief list up here of my perfect cubes, what numbers am I looking for? Let's see, 1 and 2 times 2 times 2 is 8, and 3 times 3 is 20 times 3 is 27. Let's get the right number. So we want 27, and then 4 cubed is 64, and 5 cubed is 125. And I won't need to go any higher because I see in my list over here, my 192 is the highest number there. So let's see here. Let's break out. Is 8 a factor of 24? Yes, it is. So that means I will change this one. I'm going to change this one into the cubed root of 8 times the cubed root of 3. Break it apart again. I'm going to put the rational one that's going to be rational first. Minus 4. Now I got to think of the factors of 192. Let's see, 1 and 192. And notice I can do it 2 ways. I can get the calculator out, but I always write these down so I can keep track of stuff. 192 divided by 2 is going to be 90. Let's see here. That would be 18, 196. And then 3. Is that divisible by 3? Let's get the calculator out here. 192. Let's clear that. Let's do 192 divided by 3. 64. Hey, there's the perfect cube that I'm after right there. 64. Boom. So it's 4 times the cube root of 64. And I got to get my cube root in here right there. and then I'm going to say times the cubed root of 3 plus, I have a cubed root of 3 sitting here, so I'm just going to leave that as it is. That's an irrational number, so I just get to copy that. So let's take a look at the first term. What does this become? Cubed root of 8? Well, that's 2. Times the cubed root of 3. I'm just going to leave that little guy right there. Minus 4 times, let's see, the cubed root of 64, that's 4. Because 4 times 4 is 16 times 4 is 64. So that means I have 4 times 4, which is 16. Then times the cubed root of 3 plus the cubed root of 3. Now let's take a look. Do I have common factors? I have a common factor of cubed root of 3, cubed root of 3, and cubed root of 3. So that means I'm going to add and subtract my numbers in the front of those irrational numbers. I have a 2 minus 16. That is 14 times the cubed root of 3. What number would I write here? I would actually pretend that there's a 1 there. So there's like a 1 written right there. So I have 2 minus 16 is negative 14. Negative 14 plus 1 is negative 13. So I'm going to have a negative 13. Negative 13 times the cubed root of 3. Okay? Negative 13 times the cubed root of 3. And that's it. I'm done with that one because this is irrational. This is as far as simplified as I can pull out perfect cubes. Another example for you. This one has 3 terms in it also, but now we have the variables showing up on it. So how do I deal with the variables? Well, when I look at these variables, I'm going to see, do I have common factors in there? Can I simplify some out? So let's see. I have square root of 20, and I break it apart to the square root of x. 20 has a perfect square factor, it's 4. So I'm going to say the square root of 4 times the square root of 5 times the square root of x. Break all those numbers out separately. Minus 6 times the square root of, hey, 16 is a perfect square, so I got 16 times the square root of x. And then plus 45 times the square root of x. All right, so now what? Well, 2, this is going to be 2. So 2, now square root of 5 is irrational, and so is square root of x. So I can multiply those back together with my product rule times 5x minus 6. Well, the square root of 16 is 4, so 6 times 4 is 24. So minus 24 times the square root of x. And there's nothing to do with that one, so it's 45 times the square root of x. So now what? Well, let's see, are there like terms? The square root of 5x is not a same factor as the square root of x. So this is the only term that has a square root of 5x in it, so I'm going to write it down. 2 times the square root of 5x. Now, negative 24 times the square root of x plus 45. So mentally, I'm going to take and do 45 minus 24. So that's a plus, and it's going to be 21 times the square root of x. And there we go. There we have it. And I'm going to be done with my simplifying at that point. Okay? All right, what do I do now if I have a problem where the roots that I'm after are different? How far and what can I do? Well, we'll simplify this down as far as we can. And then we're probably going to end up with 2 different terms here because I have a fourth root and a square root. So looking at this together, I have the square root of the fourth root of 32, and the square root of 32. So the fourth root of 32, I'm looking for perfect fourths, so I better make that list again quick. So that'll be 1, and 2 to the 4th power is 16, and then 3 to the 4th power, wow, that's 81. So I don't need to go any further. I'm probably looking for a factor of 16 in here, aren't I? So the fourth root of 32 is like the fourth root of 16 times the fourth root of 2 minus, now, perfect squares. So I think of my perfect squares. 16 is also a perfect square, so I'm going to change this to the square root of 16 times the square root of 2. So now to keep simplifying, what is the fourth root of 16? That is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So there we go. Times the fourth root of the square root of 2 minus 4 times the square root of 2. All right, now both looks like they have a radical of 2 in it, but looking, they are different. This is the fourth root. This is the square root. So because I have different radicals here, I can't combine any further. I stop right here. I've taken out all the perfect roots that I can take out, and then I've put them, multiplied them back together, and I have to leave this as an expression this way. All right, if you have any questions, they're up to 10 minutes on the video now. If you have any questions, be sure to come and ask me. Here's what I'm going to want you to do out of your book to start with. I want you to start with page 2, or I'm sorry, not 2, page 440. And I want you to do numbers 1 through 9 odd, and 17 through 31 odd. And the reason I've done the odds is so you can check answers in the back of your text. You get that feedback right away on how you're doing. So be sure to check your answers. Turn this in when you get done, and then you'll be able to ready to move on. Let me know how I can help you.